Hello YouTube and welcome to Heathen Hacks. Today we're going to unbox, set up and review the K10 Pro, an open source full-size customizable mechanical keyboard from Keychron. We'll talk about its specs, features, basic configurations, do some simple sound test comparisons, and disassemble it to see what's under the hood. Let's go! For a bit of context, I've been using my K70 RGB Mark II with Cherry MX brown switches from Corsair since 2019. Unfortunately, I had to replace it with my CM Storm CK350 with Otemu Blue switches backup keyboard last January because the RGB LEDs on it went haywire and it annoyed me. But just a few months later, some of the keys on my backup keyboard had started chattering and sometimes would not even work. And now here we are. So I just received this a few hours ago. This is the fully assembled version, by the way, a bare bones version, and both ANSI and ISO versions are also available. Here are some of its specs and features. It's a full-size hot swappable mechanical keyboard because I can't live without my number keys and I want to try different switches without buying different keyboards. It's compatible with both macOS and Windows, but I think they forgot to mention Linux, since I'm using Linux at this very moment and I'm not having any issues. It uses an open source firmware called QMK and an open source configurator called VIA. VIA is a graphical user interface for programming QMK firmware, which is perfect because I'm using an open source OS and of course an open source application to write my scripts. It has both wireless and wired mode. You can pair up to 3 devices with it by using its Bluetooth function. It uses screw-in stabilizers, or as they like to call it, stabs, so if you don't like the feel of the ones installed, you can easily replace them. It has a powerful ultra-low power ARM MCU which is equipped with 128K flash and a polling rate of 1000 Hz out of the box. It has a 4000 mAh battery which lasts for up to 4 weeks if the RGBs are disabled. It has more than 20 stock RGB LED effects and a sound absorbing foam. Alright, let's open it up then. Inside the box, we have this foam. I wonder if we can use it for additional sound dampening. Some sort of a reminder to not accidentally bend the pins on switches, the quick start guide, keycap set for Windows mode. The default installed keycaps are for macOS, by the way. Kinda sad that there are no available keycaps for Linux, but oh well. The provided Allen wrench and Phillips screwdriver for disassembling the keyboard. Don't really have a use for it since I have my own tools, but it's awesome that they're included. An empty plastic bag, which I guess is where the switch puller and keycap puller are stored. A braided USB-A to USB-C cable for both setting up the keyboard and charging. By the looks of it, it's just about more than a meter in length, which is quite short to be honest, but we can use other cables if we need longer ones anyway. As you can see here, I'm using a third-party one. It's a right-angle USB-C to USB-A cable from Ugreen. And finally, the keyboard itself. Despite it being mostly made of plastic, this is really heavy. I think this is even heavier than my K70 which has an aluminum frame. As seen right here, it weighs more than 3 pounds. Here's the user manual which is in both English and Chinese. It has a flat bottom case with a total of 5 rubber feetsies for extra grippage. Grippage? Is that even a word? I don't know. It also has 2 pairs of adjustable feet. It has a typing angle of 3.5 degrees when the adjustable feet are folded, 7 degrees when the smaller one is used, and 10.5 degrees when the bigger one is used. As you can see here on the bend test, it's really sturdy too. Now let's see if its Bluetooth function works. According to the quick start guide, we have to press both FN and 1 keys for about 4 seconds to pair it. So basically, FN plus 1 for device 1, FN plus 2 for device 2, and FN plus 3 for device 3. Alright, my PC's Bluetooth is already on. Click on add device and let's see now. Oh, there it is. Select device, click next, and it's connected right away. That was really quick, huh? For us to see what's under the hood, let's disassemble it. But first, let's turn it off. To disassemble it, I'm going to use my 142-in-1 Tech Toolkit again. Click right here to check it out, by the way. We're gonna need this one, this one, this one, and this one. To take off the frame, we have to take off 8 screws using this 2.5 hex bit. These screws are all magnetic, which is good. Forgot to mention that this keyboard is also equipped with Keychron's pre-lubed K-Pro red linear switches. And it has south-facing RGB LEDs. LEDs, no! Sorry about that. Continuing on with the disassembly, for us to have access to the inside of the case, we have to remove the screws that are attached to the steel plate as well. And to do that, we have to remove the keycaps first. And just like magic, there it is. Now we have to unscrew a total of 13 screws located at these spots to remove the switches, steel plate, and the PCB. For that, we're going to need a size 1 Phillips bit. These are all magnetic as well. Okay, let's lift this up to remove both the steel plate and PCB. Apparently, the sound dampening foam is sandwiched in between the steel plate and the PCB. Now let's unplug this, not sure, but it looks like a JST connector to inspect the bottom case. So this is the underside of the PCB. Keychron K10 Pro PCB version 1.2, ANSI, Keychron QMK keyboard, more to come. These gold screws right here are the screw-in stabilizers. And I believe this one is the... not sure if you can see that. Hold up, let me get some macro extensions. So the part number on this chip is CYW20730. And according to its datasheet, it is a Bluetooth 5.1 compliant, standalone baseband processor with an integrated 2.4 GHz transceiver. It is ideal for wireless input device applications including game controllers, keyboards, 3D glasses, remote controls, gestural input devices, and sensor devices. The built-in firmware adheres to the Bluetooth Human Interface Device or HID profile and Bluetooth Device ID profile specifications. The CYW2730 radio has been designed to provide low power, low cost, and robust communications for applications operating in the globally available 2.4 GHz unlicensed ISM band. It is fully compliant with Bluetooth Radio Specification 5.1. It has a wide array of features such as these things. Just search for the part number and download the datasheet if you want to know more, or just click the link in the description down below. Back at the front, here we have the preloop stabilizers as well. Right here, we have the connection for the battery. Here's the USB-C port for both charging and data. These are the mode switches. This right here is the connection to the CYW2730 standalone baseband processor, or basically the 2-in-1 MCU and Bluetooth module. And here we have a TP5000 chip. According to Components 101, it is a single-cell lithium-ion or LiFePO battery charger. It has a built-in power MOSFET, 0.1 to 2 amps programmable charge current with 10% to 100% pre-charge current, max input voltage of 9 volts. It has over temperature, over current, and under voltage protection. I think this is a step above the very common TP4056 charger module. I'm not sure though. So the bottom case alone, together with the silicone bottom pad, is already quite heavy. At first I thought that the battery would play a major role when it comes to the weight of this thing, but I was wrong. Okay, so this is the aforementioned silicone bottom pad for additional sound dampening. We have to remove it to have access to the battery. Let's unplug the battery's JST connector first though. Apparently, the bottom of the silicone pad looks like this. I wonder if it uses the same material as those silicone soldering mats. This right here is the 4000 mAh battery, and that's pretty much it really. Alright, let's put it back together except the keycaps for RGB effects demo because, well, can't really see the RGB effects that much if the keycaps are installed. Here are the stock RGB effects: cycle left right, cycle up down, rainbow moving chevron, cycle out in dual, cycle pinwheel, cycle spiral, dual beacon, rainbow beacon, jelly bean raindrops, pixel rain, typing heat map, digital rain, reactive simple, reactive multi-wide, reactive multi-nexus, splash, solid splash, solid color, none, breathing, band spiral val, cycle all, and now back to cycle left right. As far as I know, you can also program or create your own RGB effects if you want to by using the configurator. After the RGB effects demo, let's reinstall the keycaps. So this is what the RGB LEDs would look like when all the keycaps are installed and when the lights are off, by the way. As you can see, if you rely on your keyboard's RGB LEDs to see the legends on the keycaps, well, you would be slightly disappointed. But I think it's fine though, because we can use other keycaps if we want to anyway. Now let's test the Bluetooth function further. So I have already paired the keyboard to my mobile phone and tablet. What we're going to do next is to test its switching function. Bluetooth 1 or device 1 is my PC, represented by this notepad right here. Device 2 is my mobile phone, and device 3 is my tablet. Let's start with device 1. Switch to device 2, then to device 3. Switch to device 1 again. Device 2. Then device 3. There we go. Let's move on to the battery. So when it runs out of juice, this LED indicator would flash red. To monitor how much time it would take to fully charge, I'm going to use my USB tester. Check it out right here if you want. At the moment, I have already connected the keyboard to my USB hub, which is giving it around 1.15 amps of current at 5 volts. I have also switched the keyboard from Bluetooth to cable or wired mode so that it would continuously be charged. After almost 1.5 hours, it already received 1700 milliamps per hour of charge, and the USB hub is now giving it around 1.3 amps of current. After more than 3 hours of charging, the keyboard's battery is now almost at 4000 milliamps, and the USB hub has decreased the charging current from almost 1.3 amps down to 0.85 amps or 850 milliamps. It takes about 4 hours to fully charge, and while it's charging, the LED indicator would show static red. After charging, the static red LED would turn to static green. And while we're talking about the battery, it also has a battery saving feature where the LEDs would turn off if unused for about 10 minutes. After that, let's check out VIA and do some test configurations. Now, to be able to program our keyboard using VIA, we need to switch it to cable mode first, then connect it to the computer using the provided USB-A to USB-C cable. Just like that. Okay, just to make sure, let's check if the keyboard is detected by the computer. Devices, USB devices, and there it is, Keychron K10 Pro. Alright, let's open up a Chromium-based browser. I'm going to use Brave here since VIA is not compatible with Firefox because Firefox does not use Webhead API. Not sure why, but according to some old news from 2020, it's because of some privacy concerns. Also, not sure why Brave is using the API now, but yeah. Let's enter caniusevia.com, click on Authorize Device, click on Connect, and there we go. Depending on what OS you're using, you can either choose layers 0 to 1 for macOS and iOS or 2 to 3 for Android and Windows. And since I'm using Linux, let's just try layer 2 if it would work. Well, while writing my script, I tried to switch the keyboard to Mac and iOS, and lo and behold, it's still working. Interesting. This one definitely needs some more research, but for now, here are some basic configurations that you can do. As you can see here, I have already remapped some of the keys and have made some simple macros. This key right here, the X one, since this keyboard doesn't have any dedicated media keys, I have mapped it to be my global play pause toggle. And on this square one, I have mapped it to mute. Now let's test the play pause toggle real quick. Play pause, play pause, play pause, play pause. Now let's test the mute key. Mute, then mute, mute, then mute, mute, then mute, mute, then mute. For the left Windows key, I've mapped it to macro number 0. By the way, on the macro tab under key map, we have a total of 16 macros that we can use and save to the keyboard's memory. What macro 0 does is basically just closes a tab. Instead of pressing Ctrl W, I just press the left Windows key. Going back to the extra keycaps on the keyboard, I've mapped the triangle key to hide and show the desktop. So instead of pressing the Windows key and D, I just press the triangle key, just like this. Now, to create a macro, you just need to click on the Macros tab, the transparent circle with a smaller opaque circle inside. Then, click on the macro number you want to use. Let's say macro 2 or M2. Click on the full screen button, then click on record keystrokes to, well, record your keystrokes. If you made a mistake, just click on stop recording, then undo changes or just click record keystrokes again. Then, after recording your keystrokes, click on stop, then save changes. After that, to map the previously created macro, let's click on the basic tab under key map. Pick the key that we want to map to macro 2 by clicking it. Let's say this up arrow. Then, go back to the other macro tab, the one inside key map and below the media tab, and click the macro you just saved. In my case, it's macro 2 or M2, so that's the one that I'm going to pick. For a quick test, I'm going to open a notepad. Then, press the up arrow. To delete a macro, just go back to the smaller macro tab, then click on delete. And there we have it. Alright, now let's go back to the basic tab. So if you want to remap a key, you just need to find the key that you want to remap on the keyboard above, click it, then find the key that you want to remap to it, then click that key. That's all for the VIA configurations for now. I'm thinking of making a dedicated video for this since it definitely deserves one, but I don't know. Stay tuned for that, I guess. Right, before I forget, if for some reason you're getting an error like this, even though you're already using a Chromium-based browser, you can go to VIA's GitHub page and just download the desktop version of it. That's what I did at least. I've downloaded the app image version which worked right away, and when I tried to use the website version again for this video, the browser version worked as expected. Now let's move on to the sound tests, shall we? As I have mentioned before, I have 3 keyboards. One with Cherry MX brown switches, tactile, one with Otemu blue switches, clicky, and this keyboard which has Keychron's Preloop K-Pro linear red switches. For the sound tests, I'm going to use my Maonu AU-A04TC cardioid condenser mic. Link right here to check it out, by the way. I tried to use DaVinci Resolve's Fairlight at first, but it's not detecting my microphone for some reason, so I opted to use my backup audio recording software. Let's proceed with the typing test. To preface, this is my first customizable mechanical keyboard and I bought it because of curiosity and its open source nature. I'm also not a keyboard guy. This review is from someone who is new to the hobby, so don't expect anything that technical. Now that that's out of the way, let's move on. Coming from someone who's used a mechanical gaming keyboard with blue switches for a few months, using this keyboard for the first time felt like that scene from Naruto when Rock Lee took off his weights. To elaborate further, when I first laid my fingers on it and started pressing, I was surprised by how fast it registered the keys. Probably just because of the lower actuation force needed, but it felt quite weird at first because my fingers have gotten used to pressing with a bit more force. Partnered that with the switches being pre-lubed and linear, it felt really different from what I had become used to because it's really silent when compared to the other two that I have. It's heavier as well. So far, my experience on using it has been fantastic. Setting it up using Bluetooth was effortless. It being a customizable keyboard means that you can change or replace almost everything, provided that the replacements have the correct measurements and specifications. It's hot swappable, so you can just replace the switches without desoldering them if ever you wanted to use something different. It's compatible with all operating systems. It has an open source firmware and graphical user interface, which means that it would be easier to find or fix bugs and would be generally safer in terms of privacy, since everyone can see the source code and can warn everyone if ever the source code has something sussy-wussy in it. And, just like most wireless peripherals, you can still use it while charging the battery. And speaking of the battery, it's really nice that it's easily detachable, which means that if ever the battery dies, it can be easily replaced or even removed when opting for just using wired mode. The capacity of the battery is really good as well because a 4000 mAh battery for a low-powered ARM Cortex MCU would last for quite a while. Keychron providing the tools needed for this assembly is also a nice touch since not everyone has tools available at their disposal. The CYW2730 standalone baseband controller processor that it uses is really powerful, and it has quite a lot of features as well, so in the event that the PCB of the keyboard dies, I'm quite certain that we can use it for something else if it's salvageable. The pre-programmed or stock RGB LED effects looks awesome too, and of course, by using the VIA configurator, we can even make our own LED effects. Speaking of which, the VIA configurator is super noob friendly and easy to use as well. I mean, as you have seen previously, you don't even have to program or code anything. Just click this, click that for key remapping, and click this, type that for macros. Granted that some of it was quite confusing, one can't deny the fact that for making basic configurations like key remapping or macros, it's really easy. Also, even though it's mostly made of plastic, The weight of it feels like it's a premium keyboard. It's quite cheap as well when compared to my K70 from Corsair. And of course, it's not all sunshine and rainbows. Just like most mass-produced consumer products, this keyboard has its own drawbacks too. Well, to me at least. Not a deal breaker, but the lack of num-lock indicator LED for me is a bit disappointing, especially because the keyboard has space for it. Just take a look at that! It can totally fit 4 more LEDs. The included keycaps not being shine through was a bit disappointing for me as well. I mean, as you have seen previously, the legends on the keycaps are not visible at all when the lights are off. So if you depend on the RGB LEDs of the keyboard to see the legends on the keycaps, you can't do that with this keycap set. It's a good thing that it's easily replaceable though. Another non-deal breaker drawback for me are the south-facing RGB LEDs. As far as I know, with south-facing RGB LEDs, the legends on shine-through keycaps are not that bright, unless using a side-printed keycap set. Another thing to note is that it having Bluetooth as its only mode for wireless connection, you can't enter the BIOS using the keyboard because it's not connected to the PC's Bluetooth yet. And if you're dual booting and your main OS is not at the top of the selection, you would definitely have a hard time unless you use the keyboard in wired mode. In my case, I'm dual booting Linux and Windows 11. I mainly use Linux and it's at the top of the selection, but I've set up my Grub to have 15 seconds of leeway before automatically selecting an OS. So, every time I turn on my PC, I have to wait 15 seconds for Grub to select Linux automatically, and then wait a few more seconds for the keyboard to connect to the Bluetooth before I can even type my password on the login screen. I don't know, maybe a dongle would have been better? Going back to the physical parts of the keyboard, I think for future versions, they should definitely change the slide switches to a thicker one. I mean, just take a look at this one. These are the slide switches that connects the mode switches for OSs and USB off and Bluetooth modes. As you can see, they're really thin. The toggle itself, this thing is okay, but the sort of stem that connects it to the inside of the switch is really thin and flimsy. They easily break. Judging from what I've seen on the unofficial sub, quite a few people have actually experienced the same fate as I did. Also, according to the unofficial subreddit, their customer support or after-sales support sucks, but my experience with them has been good so far, so I don't know. Your mileage may vary. Now, this is not part of the review, but more of an additional story that is related to customer support. Earlier this afternoon, May 12, when I tried to turn on the keyboard, the USB off BT mode switch was not working. It's just sliding. When I disassembled it to take a look at what happened, the small toggle that is connecting the slide switch to the mode switch was apparently broken. It's an easy fix for me, so I ordered a set of 8-pin, 1-pole, 3 throws or single-pin, 3 throws SMD slide switches right away to replace it, and then proceeded to desolder the one on the PCB. However, while I was in the process of desoldering, some of the traces on the PCB were also removed, possibly because my soldering iron was too hot. Right now, I can still use the keyboard because there was a little piece of trace left on the USB or cable mode part of the switch, so I just bridged the connection using a wrapping cable, but I can't use Bluetooth or turn it off anymore. I have also disconnected the battery to be safe. So I emailed Keychron what happened and have asked them if I can purchase just that certain PCB and have sent them some images and videos together with my email. And they said that they're going to send me a replacement PCB. To be honest, I did not expect anything since the PCB trace being removed was my own fault, so I thought that it would not be covered by the warranty. Took a little back and forth with customer support and about 2 to 3 weeks of waiting for the PCB to be delivered, but they still sent me one for free. Now that's a good after-sales support experience on my book. So here's the replacement PCB that I've requested. As you can see here, the toggle switch on this one is intact. My original plan was to just fix the old board so that I would still have a replacement available for future uses. But unfortunately, as mentioned earlier, some of the solder pads on that one has been stripped away by my soldering iron. Now, I could try and scratch the PCB to get to the copper and hook up the replacement toggle switch to that. But the connection of it would be compromised since it would be used all the time. So upon considering that potential issue, I have decided to not proceed on fixing it and would rather just use it as a donor board for the new one. Now here's the old PCB. As you can see here, after disconnecting the battery, I have also covered it with some Kaftan tape to protect its terminals. I've also added some tape onto the traces that I have bridged. Here's the bridged connection. What this does is to essentially enable the USB cable or wired connection mode permanently. I did that to still be able to use the keyboard while waiting for the replacement PCB. The 2 pins at the middle are common connection, and evidently the other common pin or connection had been completely stripped. Before we reassemble it, first, let's see if the replacement PCB is working. Okay, let's switch it to Bluetooth mode, and there we have it. In conclusion, it's a fantastic keyboard. There's no significant or noticeable latency or delays when using the Bluetooth mode. Switching from one device to another is seamless. The battery lasts quite long even if the LEDs are turned on, about 3 to 4 days I think. The typing experience feels really good, still making a lot of typos because I'm still getting used to it though. In my experience, their after-sales support is also good. But they could have changed or added a few things like some bigger or tougher slide switches on the PCB, some additional option for shine-through keycaps, and maybe some optional Linux keycaps instead of Windows that can be selected before purchase, and additional LED indicator for the numlock. Overall, I can say that I'm really satisfied. So yeah, thanks for watching and see you again next week. Maybe.